screen. Can you just confirm you're able to see my slides?
Yep, I can see them.
Thank you. So yeah, very interesting talks by Alain and Bill. Thanks for those. Mine is going to be a bit more how the trend works in practice and what we've kind of experienced at StatsCan. So I apologize.
I'm sorry to interrupt, Steve, but it's not full screen.
Oh,
yeah. That'll probably help people. Okay, perfect.
Is that a little better? Okay.
Yeah, that's great.
Okay, thanks. Yeah, so I apologize for the title not being a bit more specific, but essentially what I'm going to talk about is our experience working with trend cycle estimates during the COVID-19 pandemic, and some thoughts we have on how we may make some adjustments going forward. So in terms of my outline of my talk, I'll first talk a bit about what is a trend cycle, some sort of definition. Then I'll go on to the methods used for estimation at Statistics Canada. So we recently did a study to identify a method to use, and we've applied that, and I'm going to talk about some of the things we've observed during the pandemic with that method, and then move on to some other options we're currently considering, and give some idea of what our preference is at the moment, but it's work in progress. We still need to do some communicating it throughout the agency and get some approvals. So that's what I'll end off with are the next steps. So first of all, what is a trend cycle? So I looked in the literature for a more formal definition. I wasn't able to find sort of a widely agreed upon mathematical definition, but I did find a lot of different sources where there's some descriptions. And those descriptions talk about what the trend cycle looks like, what types of frequencies are kept or not kept, what it does and doesn't include, how it's calculated. So those kind of, there are a lot in common with these descriptions. And essentially, I think one thing I took out of it is that, you know, the high frequency cycles are removed and the lower frequency cycles are what's included or what remains in the trend cycle estimates. One other aspect of what the trend cycle or definition is how it should handle shocks. So I think over time, you know, in general, we've come to a sort of a conventional agreement about what types of shocks should and shouldn't be included in the trend cycle and which ones should move to the irregular. So in terms of the types of events that we would put into an ARIMA model, or what types of regressors, if it's something that we judge to be a transitory shock or something that'll be short-lived, we tend to put it into the irregular. So those would be regressors like the additive outlier or temporary change. If it's something more fundamental or permanent or a structural change in the level, we tend to put that into the trend cycle component with a level shift or a ramp. But there is some gray area in between where I think we need to make some subjective calls on which way we want to treat a given shock. And we've seen that a bit in the pandemic with you know, some shocks where you could look at it in different ways. So to come up with a target, we can apply some generally accepted methods. So what I've done is I've taken just a data series from our COVID period, and I've applied X12 ARIMA with automatic options, including detection of AOs and level shifts, because the X12 ARIMA methodology will actually put those into the corresponding trend component or irregular component. And I've done the same with the Tramo seats options in the X13 software, again with automatic options and automatic detection of outliers. And what I found, you can see on the graph here, the dark blue line is the trend coming from the X ARIMA line, or X12 ARIMA. It's almost indistinguishable from the Tramo seats trend. And I've included the seasonally adjusted series in gray, so you can see how both of the resulting trends are smoother than the original seasonal adjusted, and the resulting trend cycle is very similar. I also wanted to mention that even in times when there's some really extreme movements going on, the results from that automatic detection of level shifts and AOs seems quite intuitive. I tend to agree with where the algorithms were assigning those types of effects. So I thought that was a positive note. In terms of how we produce trend cycle estimates at Statistics Canada, as I mentioned, we did a study to identify a method to use, and that method set out a few criteria, and we evaluated some different options. So some of the properties that we were looking for in our trend cycle estimates were to minimize revisions as further periods are added, maximize the smoothness of the trend cycle line compared to the seasonally adjusted line, and also to help with the detection of turning points. So both to minimize the lag in detecting them in real time, but also minimizing the number of sort of false positive turning points we see, where something looks like a turning point, but then when you add more periods, that spike or trough disappears. So those were sort of the properties of the resulting estimates, but from a higher level, we wanted to have some characteristics of the method itself. So we wanted it to be linear or additive. So for example, here in the past, we were using a method for trend cycle estimation where if you had a hierarchy of series and you were publishing the details and the totals, if you produce a trend cycle for each detail and aggregated them up, you get a different result from if you add up the components and then produce a trend cycle on the aggregate. And we wanted to avoid that situation because it can lead to some strange situations where the components are all going up, but the total's going down and those kinds of things. So those are very difficult to explain to the users. So that's something we were trying to avoid with the method we choose. And also we wanted something very simple and reproducible for our users, so that we could produce the high-level trend cycle estimates, but users would be able to produce them themselves for custom series or for more detailed estimates than what we're providing a trend cycle for. So based on these criteria, the method that we selected for use at StatsCan was the Cascade linear filter, which comes from a paper by Degum and Luati in 2009. And we've been actually producing trend cycle estimates since 2015 according to that methodology. And it's essentially a linear filter applied to the seasonally adjusted series. And in the paper, the way it was developed was the objective was to have an approximation to this earlier work of Dr. Dagum in 1996, which we internally we call it the Dagum two-step. But essentially, it's a method where you take the seasonally adjusted data, and through 2 passes of X12 ARIMA that include some forecasting, some outlier detection, and some smoothing via the Henderson filter, the D12 table in your second pass is an estimate of the trend cycle that is the final output from this 2-step method. And this Dagum-Luati Cascade linear filter approach approximates that 2-step filter, but through a linear smoothing filter. I'll just mention too that in some of our evaluations, what we found is a simpler approach to derive the asymmetric filters gave us some better properties. So the approach that we're using, we called it cut and normalize. So for any period in real time, if you don't have the future period, we dropped that weight and then rescaled the weights where we did have the corresponding estimate to sum up to 1. And that gave us some nice results. So I've included the references down below. The graph on the right, the orange solid line is the method that we selected, and the yellow dashed line is the method that's proposed from Dr. Dagum in 1996. And you can see that they're quite similar, although in those initial large shocks and drops from the pandemic, there is some difference, and that's due to the outlier detection that's included in the Dagum two-step. Where some of the impact of some of the individual observations is kind of smoothed over a little bit more. So with that method, as I mentioned, we've been using it to publish estimates for a number of years now, but we're very careful about how we present those estimates in our publications. So it's really intended as a visual complement to our seasonally adjusted series, so that if we have a noisy series, it helps the users to really understand what the fundamental underlying movement is. So when we do present it, on the left is an example of one of the graphs from our publications. We're very careful to indicate that it's susceptible to revisions, especially in the sort of the endpoints. So we actually use a dotted line rather than a solid line to represent the last four estimates, the current and the 3 previous months. And we have multiple notes to describe that along with the publication. We also provide a lot of documentation to make it transparent. So in our note to readers that accompanies our releases, we have a link to this trend cycle estimates frequently asked question. I've copied the link down below, but that really gives some tips on how to interpret the trend cycle, how it's calculated, and some of its strengths and weaknesses. And then within that trend FAQ document, we also have a link to a more detailed document that actually gives the weights and gives all the information that a user would need to reproduce our trend cycles, and also to calculate them on any other series. And we specify that it has to be a series where the seasonality has already been removed, or there never was seasonality, because it doesn't remove that component. So that's where we were. Just going back to this graph, it's from before the pandemic, obviously. This is actually February 2020, so this is before we started to see those effects. And it's kind of shocking to me how much smoother our series were. It sort of takes me back to a simpler time. But now during the pandemic, we had some very significant economic shocks starting in around March of 2020. And I'm going to present two scenarios. One scenario, which was common for a lot of our series, where we had a very short-term recovery. There was a big initial drop, but within 3, 4, 5 months, the series had returned more or less back to its previous level, and the trend kind of continued onwards in the direction it had been going. In a lot of cases with a little bit more irregular, a little bit more volatility, but in general, the trends were kind of picked up where they left off almost. So on the left, I've got a few of those series from our published results, and on the right, I've chosen one which I believe is our retail sales series. And with the current methodology, you can see what the trend cycle does. It actually follows that dip for a short period of time, smooths it out a little bit, and then goes back up to the previous level. So that's one scenario that was fairly common across a number of our indicators. The second scenario is a more extended recovery, or a more gradual recovery. So I've got a few examples here from our releases, and the one on the right shows how our trend cycle filter reacts in that situation. And I'm going to go into some more detail on some of the features that we noticed with the trend cycle in that situation. The graph on the right is actually an example from our restaurant sales, but some of our really top level key series fell into this category. For example, total employment was this was kind of the pattern that we saw. One other thing I'll mention here is that you do see in the recovery, it's not a slow and steady recovery. It kind of has some waves, and those, the timing of those corresponds to some of the lockdowns and reopenings that we had in our economy in Canada with the recovery. So you see that nicely, and you also see that the trend cycle tends to smooth those out a little bit. I'll talk a little bit more about that. So in real time, we observed a few things that we expected. This graph on the right is similar to what Alain showed with the real-time estimates, where each of the lighter blue lines is actually a trend cycle series, and all we're changing between them is the endpoint of the seasonally adjusted that's going into that trend cycle. The dark blue line is kind of the final, or the current trend cycle that we have, considering all the information that we now have. So what we're seeing is, and sorry, the dashed line is the seasonally adjusted. What we're seeing is, as expected, larger than usual revisions, given the volatility that we're seeing, especially around the turning points. If you look at the sort of the bottom of the dip, you can see that the trend cycle was a little slower to react and recognize that recovery starting, and especially a bit conservative in terms of the pace of that recovery as those revisions were large. And similarly, at the start of at the onset, when there was the initial drop, we can see that the trend cycle was pretty heavily revised as a few more months came in that were at that very low level. There is some impact on the reacting to the pace of change and the detected turning points. And there's one particular counterintuitive bumps. If you go back a few months before the start of the pandemic, we see this little bump in the trend cycle that wasn't there in the seasonally adjusted. And that has to do with the weights in the linear filter. Actually, the T-6 and T+6, the weights are negative. So when you see this huge, large drop, it causes a bump in the opposite direction 6 months previous. So that was something that we found was a little difficult to explain to users. It does help with kind of the efficiency of the filter during regular times, but that's sort of the drawback, is that when there is a large change, it can cause some kind of an echo, or an inverse echo 6 months before and 6 months after. So going forward, we'd like to have something in place to deal with these kinds of shocks in real time as they happen. And we feel that should be driven by what's best for the users. So the options would be to publish our concurrent estimates as they evolve in real time. This is what we did throughout 2020 with the appropriate caveats. The other option would be to temporarily suspend the publication of the trend cycle until we have those future periods to allow us to estimate it and reduce those revisions. We feel it would be important to have some kind of objective criteria that would be used to start and stop. Excuse me. But in the context of a visual complement to our seasonally adjusted, we do feel there is some utility to the users to provide that trend cycle in a noisy period. Excuse me. even if we know that the revisions are expected to be larger. So that's our current plan going forward, is to continue to publish the trend cycle even when there are large shocks. So now looking back, now that we have a couple of years of data since that initial shock, a couple of things we noticed with sort of the retroactive or the final trend cycle is that it does affect the turning points. So the turning point at the onset of the pandemic in the seasonally adjusted is in February. In the trend cycle, it's pushed back to September of 2019. So that's something that may be strange to users. And even in the recovery, it's moved by 1 month. The turning point in the essay is in March, in the trend cycle is in April. Just the size of the drop with the initial shock, what we see is that the shock is partially attributed to the trend cycle and partly to the irregular. And depending on the length and duration of the shock, it probably should go to one or the other. So what's happening here is we're having an irregular component that's of the same sign for a number of months. So it pulls the trend cycle down, or in a direction, but not completely. So there's some kind of smoothing that happens that effectively, I think it splits the impact between the trend cycle and the irregular in that case. And the other thing that we wanted to point out is that the Cascade linear filter that we're using does a nice job smoothing out the bumps and dips as expected during the recovery once things are a bit smoother. So it does tend to filter those to the irregular because they are positive and negative. There's not a persistent pattern in the irregular sign during that period. So what we'd like to do is come up with possibly a modified Cascade linear filter that would avoid some of those issues with large breaks. So I've got here an example where we have a trend cycle, what we consider a trend cycle break. It's a longer lasting shock with a gradual recovery. And there's really a sort of a single really significant shock. So we'd like to, we suggested a few different options. The first would be to impose a level shift directly into the trend. So what we would do is estimate the level shift in an ARIMA model, adjust for that level shift, and apply the Cascade linear filter to that level shift adjusted series, and then in the end remove that level shift effect to show the drop or the increase, but in this case a drop in the final trend cycle. So that's the red line in this graph. You see that it drops almost completely as far as the seasonally adjusted, and then there's a gradual recovery that happens. The other two options are similar. The first one I'll talk about is a two-sided segmented Cascade linear filter. So what we do in that case is we break the series into two pieces at the point of the shock, estimate the trend cycle for the first segment and the last segment with the Cascade linear filter and the asymmetric filters around the break, and then we join those two segments together to produce the trend cycle. And that is the green line in the graph on the right, which is more or less the same as the other lines for most parts, except for that initial drop. Where it doesn't quite go as far as the level shift being formally imposed. The third option is sort of a variant on the two-sided segmented CLF, which is we do that on only one side. So we estimate the entire trend cycle using the Cascade linear filter, but then we take the piece after the shock, and using that as an independent segment, we apply the Cascade linear filter with the asymmetric filter, and we overwrite only the piece of the trend cycle after the shock with that segmented. So it's only segmented on one side. That has some impact on the size and the drop of the recovery, and that's the purple line on the graph that you see on the left, which doesn't drop quite as far as the others. The idea with these segmented is that the estimates on the other side of the break wouldn't affect the trend cycle for the periods immediately after or before the break on the opposite side of it.
Steve,
yep.
You have 2 minutes left.
Okay, I think I'm on track.
Great.
So for a break that we should be attributing to the irregular, the way we would identify this is two shocks or significant level shifts in the opposite direction that are within close proximity of each other. So sort of a drop and then a rebound. So we have analogous options to those three that I mentioned for the trend cycle breaks. The only difference is that now we would have three segments because we have two breaks. So we would use as described before and after the breaks, but in between we expect we'd have a short series. So we'd use some kind of a linear interpolation between those 2 points to connect through the gap. And that's the same in all three of these options. So our preference out of those three was this two-sided segmented CLF. Break the series, use the asymmetric filters before and after the break. We found that it very closely approximates what I'm calling our target. You see that on the right for both the trend cycle shock and the irregular shock. It's quite close to the D12 that we get from X12 ARIMA. But it is a completely linear process. There's some loss in transparency. It's not quite as simple as our previous method, so we need to specify the breakpoints to our users so they could replicate it. One thing we like is that it's order invariant. If you were to reverse the order of the seasonally adjusted series and apply the trend, you'd get the reverse order of the trend cycle, which wouldn't be the case with the one-sided, for example. There's some subjectivity on which half is one-sided and which half is not. And it preserves those desirable properties that we established when we did our initial study of the Cascade linear filter in terms of revisions, detecting turning points under ordinary times. So it's more of a tweak to the method than it is a complete different method. So our next steps, as I mentioned, this is still in progress. We need to gather some more feedback from our analysts for specific programs, and then formalize a standard method for the agency's publications. Again, we're leaning towards this two-sided segmented CLF, but there are some parameters that need to be defined and fine-tuned around there. What do we mean by a significant level shift? Is it a t-value? Should it be 5? Should it be something else? That's work we still need to do. And for the irregular breaks, if there's 2 level shifts, how close together do they need to be for us to consider it irregular? I put 6 months here, but that's definitely up for discussion. After that, we would then need to update our systems and our calculations and the documentation that we provide to users. And we're hoping to start to publish trend cycles according to a revised methodology in 2023. That's the end of my talk. So thank you very much, and I'm happy to take any questions during the question period.
Great, thank you, Steve. Okay, so there was a little bit of chatter about Steve's talk in the chat. So did anybody want to unmute themselves and ask any questions or say anything? Or any questions for the first 2 speakers? Well, Steve, I don't know if you wanted to take a look at the chat and see what I think it was Bill and Michael mentioned. I don't know if you wanted to comment on what they said.
Yeah, I was just looking through those. I guess it's kind of touching on sort of the philosophical aspect of what should and shouldn't be represented in a trend. And I agree that I think it is a lot more vague than what we think of as seasonal. Although with our experience in the pandemic, I mean, I think there is a lot more questioning about what is seasonal. You know, if there's a year that's not typical, what is the relevant seasonal pattern for that year? I think that's a topic of some discussion, at least at StatsCan. But yeah, I would agree with both of those comments.
This is Bill Bell. I'd like to sort of follow up on that, and I thought your example is just so interesting about the conceptual difficulties in dealing with extreme events, and you know, I had in mind before you got to it putting in a level shift. But if we look at your graph, you kind of need more than one, because it has that dip and then it climbs up. And you know, we've been using runs of outliers to deal with pandemic effects, and you know, you can, in doing that, you can put in different types. And one thing that occurred to me is, you know, you might want to put in some AOs, but although AOs are, you know, would generally be assigned to the irregular, you know, when you're creatively using them for something like pandemic effects, you can make a case for putting them in the trend if that seems appropriate. And then it goes to the question of what is the trend supposed to mean? And I think it depends on what a user would be looking at. You know, if you think of the pandemic as driving the economy and you want to see that in what's called a trend, then if you use some AOs to capture some of the pandemic effects, then those could go in the trend. On the other hand, if in thinking about trends, somebody is asking the question, well, what would things have looked at without the pandemic? Then you don't want to do that. And, you know, there's no right answer. It depends on what people are looking for. I think in the case of the pandemic, mostly you want to see those effects. But for some other, you know, blips that show up in series, sometimes, you know, it's not so clear. And anyway, so that goes to the vague notion that we're trying to deal with.
I agree. I think sort of the approach that we're thinking is, you know, we have this trend cycle that's available for a given purpose, which is really a visual complement to explain the underlying level of the trend cycle. But for some types of analysis, some analysis questions, it could be a very different trend cycle that you want to estimate. So, you know, we want to sort of leave it open that there may be a better option for a given context.
Okay, well, thanks everybody. I guess we will wrap it up then. I think the main room is still open a bit if you wanted to jump into there and you know, finish up with what's happening and with those talks. But thank you so much for joining this breakout session and for participating in the Seasonal Adjustment Practitioners Workshop. It was very interesting, and I was especially happy to, you know, hear from international colleagues. So that's always exciting for me. Anyway, thanks again, and we'll see you next time.